So the New Zealand climate change science space is kind of different from other rich countries in the sense that we have this very strong heritage in processes and observations studies of climate, but we haven't paid anywhere near as much attention to how those integrate, how those fit together as other countries have. So climate modelling is something that's been a little bit of a poor relation of science in New Zealand, and yet it is the fundamental way you actually end up forming inferences about climate change. If you have a process that's telling you that it's going to rain more, and then another study that's telling you it's going to rain less, how you square those, how you tell a physically coherent story in a way that minimises the errors between them, requires some sort of model, even if it's just a statistical model. But the best models we have are these fully three-dimensional, time-evolving models of climate, which are basically slightly stripped out weather models. And so New Zealand hasn't really invested that much in this area before, but it's the bit you need in order to make coherent inferences about the future. I think that's the distinctive feature from a climate science perspective. So the Deep South Challenge is a new initiative with two bits of strong, what we call additionality. So two things we haven't seen in the New Zealand climate research ecosystem before. One is that modelling component, which is pretty fundamental. It is fundamental science, it's physics and maths, computer science. And the other bit is taking that coherent picture and mapping it through to decision makers by building a sort of vulnerability impacts adaptation program to climate change. So it's those two things that we're going to do science. We're going to try and meet New Zealand's decision needs, do a better job of meeting New Zealand's decision needs, and it's those two planks which I think are distinctive about the program, about the challenge. We do build off some pre-existing work, but by and large that's pretty new capability. The plan is to do very high quality research that's world class in places and which meets the mission of the challenge, so which helps New Zealanders adapt and even thrive in a changing climate. So help them understand what's coming and let them plan for it. Our job's not to tell people what to do, it's to aid their planning. How it's different from other research schemes, I think, is its scope. Our independent science panel thought we were being pretty ambitious, actually, given the resource, which I guess has some risks, but it's also a good thing, I think, for us to stretch the boundaries a little bit. It needs to be different from what's gone before, because what's gone before hasn't really involved an end-to-end fundamental science through to how does this affect New Zealanders chain, and I think that's what we're bringing that's really distinctive. So the way we're doing that is we have 5 programs and we want them all to work closely together. We have 2 wrapping, all-encompassing programs, the engagement program and the Vision Mataranga program, which should infuse all the other research that's going on in the challenge. So the idea there is that there'll be opportunities for New Zealanders to engage right across the processes and observations, the Earth system modelling and prediction, and the impacts and implications work. And we also want to improve, we want to do work in the area of using Vision Mataranga, so we want to have improved Maori capability in those areas, have Maori researchers flourishing as Maori in those 3 other programs: process and observations, Earth system modelling and prediction, impacts and implications, as well as addressing the needs of the Maori communities up and down the country. So I think it's kind of quite a distinctive challenge. I think I like its scope. It's large, it is ambitious, but I think partly because we're small, we can effectively fit most of the relevant people for climate change, for these parts of climate change, in a room, in a fairly large room, but we can do that, and most countries can't. So I think actually our scale, in a sense, gives us the opportunity to create something quite ambitious. It also gives us the opportunity to create a shared understanding of this physical science meets vulnerability, adaptation and impacts needs.